Your favorite topic, domain. I know you guys are really excited about this.
I don't get it.
You don't get it? Yeah, here we go. Hopefully you get it when I'm done. This says f over g, so I'm going to put the f right there and then the g underneath it. So we have this. So f over g of x equals that. All right, I'm not going to simplify or anything like that because it doesn't ask me to. It just says, what can we plug into this? So the question just wants to know the domain. It says right here. So we got to take into consideration the limiting operators that we see. And there's two limiting operators that we see here. The first limiting operator that I see is a division bar. We can never, ever have a 0 on the bottom of a division bar. Okay, so like this is no bueno. 2 divided by 0, never. You can never divide by 0. That equals undefined. There's nothing. We don't know the answer to that. Doesn't exist. Okay, well, what about this guy right here? This guy has a limiting 2. We are not allowed to have a negative inside there. The index number is 2. Whenever the index number, the root, is an even number, we can never have a negative number inside of it. Never, ever, ever. So, let's go over to our denominator right here and analyze it, shall we? We shall. Let's talk about the 0 first, just because it seems to be easier. What can I plug into this x to make the denominator 0? 2 or negative 2. Ooh, very good. You guys can see that just by looking at it. But what if you can't? If you can't see it just by looking at it, you would take this and you would set it equal to 0 so you can see what you would plug in to x to get 0. So I move the 4 over to the other side to get negative 4. Then I divide both sides by negative 1. And then I square root both sides. So I get x equals plus or minus the square root of 4, which is the same as plus or minus 2. So let's bust out a number line here since we're talking about domain. At negative 2 and at positive 2, we cannot plug in. We cannot plug in negative 2 or positive 2. I'm going to put open dots on those guys. We can't plug those guys into this function. Why? Because if we plug those guys into this function, we'll get a 0 on the denominator. So, what else can we not plug into here? Anything to the left of what? To the left of negative 2? Yeah, let's try that. If I plug in something to the left of negative 2, that would be like a negative 3. Negative 3, I plug that into there. That would be a positive 9. 4 minus 9? That would be, what would that be? Are you guys following me? If I plug 3 into that? That would be a 9, and then I have 4 minus 9. 4 minus 9 would equal negative 5. And are we allowed to have a negative inside of a square root? No, we cannot. And does that negative even matter? No, it doesn't even matter. So that means positive 3 wouldn't work either. So nothing to the left, nothing to the right. What about the stuff in between? Let's try 0. Yeah, 0. If I plug 0 into this, does it work?
Yes.
Yeah, it's no problem, Okay, so is it all those numbers that are part of my domain? If you were only considering the bottom, you would be good. But what about this guy? Did you guys consider him at all? What can you not plug into the top one? Anything negative. Look, that just got rid of everything to the left of 0. So not only is that negative 2 out because he's negative, but everything else is out because they're negative also. So what are the only numbers that work? 0 works, and everything up to 2. So we write it like so. We say that x has to be less than 2 and it has to be greater than 0. Oh, can it equal 0? Yes. So we can say 0, comma. Oh, I said 2 and I wrote 0. That's funny. Okay, 0, comma 2, bracket around the 0. That's our domain for that first one. All right, let's look at the next one. We have a g over f. All right, I'm going to attack this one a little different than last time. Here's my strategy. I'm going to look at a number line, right? And I'm going to try to figure out which numbers I could plug into this. Now, I see this limiting operator down here really quickly. I cannot plug in a negative x into this whole thing. Okay, so that leaves out all of this stuff right here. All right, so I don't know how to just put an x around it, I guess. All right, next. The other limiting operator is this division bar. Can I plug a 0? in the bottom. No, I cannot, because then the bottom would equal 0, right? So I'm going to put an open circle around the 0. And then, now, can I plug in all the positive numbers? Am I good on that?
On the bottom part, yeah.
Yeah, on the bottom? Yeah, I can, huh?
On some level.
Oh, well, wait a second. What if we consider the numerator? Like this one, I can plug in all positive numbers. Can I plug in all positive numbers to this one?
Nope.
I cannot? Which numbers can I not plug into this x?
3.
I cannot plug in 3, 4, 5, 6, 7. Anything above 2, huh? Because if I plug something above 2, then I would get a number that's greater than 4. Right? Okay, so I can't plug in all positive numbers. We're stopping at 2. But am I allowed to plug in 2? Can I plug in 2?
Yes.
Yeah.
Oh, this time I can plug in 2, because even though it gives me a 0 up top, it does not give me a 0 in the denominator. Am I allowed to have a 0 in the numerator? Heck yeah, Fulio Mulio. So I'm allowed to plug in a 2. And you guys said nothing above the 2, because then that would make the inside of the radical sign negative up there. But can we plug in everything inside here? Yeah, diggity dogs. So x has to be less than or equal to 2 or greater than 0. Another way you can write this, the better way to write this, is 0, 2 with the parenthesis around the 0, a bracket around the 2. That was a good question. I'm going to throw that in here. If I'm thinking about the denominator, I know it can't equal 0.
Yeah.
So that one's kind of simple. It's like, okay, it can't equal 0, so if I plug in 0, that's why I know there's an open dot. Okay, and I know all my negative numbers are out, because you can't have a negative number inside the square root. All right, so, but what about the top? Is that what you're talking about? Like, how do I get 2?
No, because like the one before.
Oh, hold on, let me recap what she said, because it was really good. So we always set the denominator equal to 0 to see what it equals. That's why how we did that one, so that we can exclude those x values that make it 0. The top, we only care that the inside is not negative. And so, yeah, you could set this equal, let's see, we go with this. We want to see everything that would make this equal to 0 or greater than 0, because then that would be positive. And if I did that, we would have negative 4 right there, negative x squared. And then we would have x squared, and that would be less than or equal to positive 4. You square root both sides, and that would give you the values that would make this positive. Yeah, oh wait, that'd be plus or minus, sorry. Man, I'm dropping balls here. Here, hold on. This would be, switch the sign, be positive 4, right? And I square root this, square root that, so you get x is less than 2, and x is greater than or equal to negative 2. Yeah, you have to flip the sign and make it negative.
Why do you put the equal sign?
Why did I put the equal to?
Yeah, because if it...
Oh, because the numerator can equal 0. On this other one,
okay, yeah.
This was on the bottom, we could not equal 0, but we could equal 0. So this is what we got for the numerator. Everything, like x's have to be less than 2, and they have to be greater than negative 2. But because of the denominator that put more restrictions on it, we got rid of all the negatives over here. So we're just between 0 and 2. Anyways, I hope that helps. I don't know.